Hi, my name is Curtis Whitson, and this is a basic video about pipette composites. Here you see a composite on the canvas. It's a copper brownish rectangle with double line boundaries. And the composite actually represents a collection of resources, processes, and other composites. We can enter the composite by double-clicking, and we see the underlying elements. Here, two resources, an input and output file to the reservoir simulator sensor, which is the process. At this point, I'll show you how to create a composite. We'll re-enable the three elements shown here. This is the launch of a EOS-based PVT program, PhaseComp, the input file and the output file. We'll simply select all of the elements that we want to include in the composite, right-click, and use the Create Composite from Selection key. We'll rename this PVT Simulation. And now we have a top level with two composites. Now, if we run the project, the pipette project, with at this level, it'll be running both applications in both composites, and we can track that with the timeline on the view bar. If we rerun the project again, you can see that they were first run and they were run in parallel as the default in pipette commands. If we now want to just run the PVT simulation, we can set its modified status and rerun only that composite because nothing's changed in the reservoir simulation composite. Likewise, we could set the modified status here, and now only the reservoir simulation will be rerun because the PVT simulation doesn't need to be rerun as nothing's changed there. At this point, let's show the creation of a composite from two other composites. Just collecting the composites, renaming, this is the SBA3 modeling study. And we can enter the top level composite, and we see that there are the two lower level composites. We can run the project at this level. It will again run both applications in both composites in parallel. We can decide to run only one of the composites, in this case the reservoir simulation. We can enter into and do work on the underlying composites, as would be done by different disciplines. So the reservoir engineering group would be working on this composite and these files, whereas the process simulation group might be working on the other composite. So let's try to make a project where we make use of these two composites, and what we're going to do is create a project that initially runs a simulation model where gas being reinjected is simply the produced gas. But instead, we're going to take some produced well streams out of the reservoir simulator and use those to go into the process simulation in this composite. And from that process simulation, we'll be able to get out dried injection gas that we'll want to reinject into a similar reservoir model as we originally run, but using the drier injection gas. So to do that, let's first make a copy of this composite using the export command. And we'll give it a name, export reservoir simulation. Now we can go in and do an import of that same, basically it's a pipette project that we just created. We'll re-import that, change the name using dry injection gas. So now we've got three composites, two reservoir simulation launches and one PVT simulation launch. Let's set the modified status. Now if we launch the pipette project at this point, what will actually happen is that it'll try to launch all 3 applications in parallel if possible. And in reality, what we want to do is that we want to run this simulation first, take results from that simulation into this simulation, and take results of this simulation into the third. So to do that, we're going to simply flag the second composite that we've finished the first composite by identifying that this file has been created. We'll go here and create a link to the second composite. And this is a socket that's used to identify and pass information from one composite to another. So basically we can go back and forth by clicking on the sockets, and it'll tell us where it's connected with. So this is now knowing that in the second composite that the file here has been created, and then we need to flag that the third composite, its simulation process, can be started once this file has been created. And we'll do that again using the connector. And connecting it to the third composite. So again, we can just click on the sockets to go back and forth, and we now have a fully connected 3 composite project. Clean up these connector lines to make the flow look more natural. And at this point, if we launch the project, it should launch all 3 composites and their applications sequentially in the proper order. As shown here. So now let's go back to the top level and take a look at some of the characteristics we've looked at of the composite element. Basically, it's a graphical element that's copper brownish, a rectangle with a double line boundary. It represents a collection of resources, processes, and other composites. The composite name is an internal pipe nickname used for the collection of elements within the composite. Pipet can also launch itself entire projects or parts of a project. And in fact, if you launch another Pipet project, it can be done at a composite level, in which case you pass the name of the composite to be launched. We've seen in this video the use of enable and disabling of composites in all of the underlying elements, as well as use of the modified status to apply to all underlying elements. Sockets have been illustrated. These are basically sub-elements used to connect elements in a composite with elements outside of the composite, and those elements can be at any level. The Pipet execution is not affected by the use of composites because the Pipet runner automatically recognizes and organizes all elements into a single level for execution. And finally, when a Pipet project is run from within a composite, only the processes in that composite and underlying processes will be executed. Thank you for your time, and I hope you enjoy using Pipet.